I think she has missed me the host. Started recording. Yeah. Okay. Thank you. Fine. Okay. Thanks. Fine. So I think Priyanka TS is there. Today is her birthday. Many happy returns of the birthday, Priyanka. Okay. So coming back to the classes, cluster analysis. Today we are going to discuss two very important concepts, guys. These are the very helpful concepts really, which is going to help you a lot. Okay, so cluster analysis. You have very basic idea about the cluster analysis, but I have worked out many things with respect to the topic cluster analysis. Really, they are very helpful concepts. Okay, which is the current trend, I can say. Okay, in cluster analysis, decision tree, regression, ANN. Okay, and one more is association. All these are very important technologies. Okay, so when coming back to cluster analysis is used for what I can say automatic identification of natural grouping of the things. Okay, so what we are going to do is we are going to make a group of two clusters. Okay, so similar items are going to be combined, which are very near. We are going to combine that into one category, and the different items which are going to be far, we are going to combine them into one cluster. Cluster is nothing but grouping, I can say in general. Okay, as you told in the previous class, decision tree is purely a supervised learning, but clustering is not a supervised learning, it is an unsupervised learning. Okay, so why we are going to call it as an unsupervised learning? We are not going to depend on the past data in case of cluster analysis, but in case of just a minute. Yeah, the diagram. Okay, just give me 1 minute. Yeah, presentation pointer. Thank you. What we are discussing, yeah, it is purely an unsupervised learning, where we are going to doesn't depend on the previous data. Okay, so the correct number of clusters are going to be defined within a time. Okay, and this technique suggests user how many cluster would be sensed from the clustering of the data. Why we need for a clustering? Let me give you a very simple example. Now, if people take Amazon only, okay, which is such a big company, okay. Now, how we are going to divide? I told you the Amazon consists of more than 4 crore products, okay. I'm not speaking about only 4,000, 4 lakhs, 40 lakhs. It is I'm speaking about 4 crore, more than 4 crore of the products. Now, how we are going to divide the products which are very similar? There we are going to make use of the cluster analysis. Okay, so that is where the cluster analysis is very helpful for us to deal with this kind of things. Okay, so coming back, people can see here cluster analysis. This is how we are going to group the similar and which are very near items and which are very far items together, and we are going to make into one cluster. So the best example what I can give is if I take electronic devices, how I'm going to cluster now. In electronic devices, I'm having a cell phones. Okay, cell phones, all the types of cell phones come into the one cluster. Similarly, AC, all the type of ACs is going to go into one more cluster. Similarly, TVs, all the TVs are going to come into one cluster. And similarly, what I'm speaking is, yeah, refrigerators. All the refrigerators are going to go into one cluster. This is how the cluster analysis works. Okay, even this in this we are going to have k means of clustering. We are going to see in the upcoming slides. Okay, so how the application of cluster analysis works? Like for example, based on the market segment. This is the first application based on market segment. Okay, what we are going to do, we are going to categorize customers according to their similarities. That's what I told you. Now, electronic device is a common platform. On there, the similarity is like mobile phones. They are all going to go under one cluster. ACs, they are all going to go in another cluster. TVs, they are all going to go in one more cluster. Okay, for example, we can say the way of pay, and we can even see a product portfolio. People of similar sizes, they can be under same category like small, medium, and large size of clothing items. Even when we go for text mining, which is a very big kind of concept nowadays, text mining. Here the clustering helps to collect the text documents according to their content similar to clusters of related topics. Okay. So coming back here, I need to show you very, very important thing, cluster techniques. Okay, basically there are two kinds of techniques how you are going to do the clustering. Okay, one is called as Euclidean distance and one more is called as Manhattan. Both are really very, very important. I have worked on it. I'm going to show it how you are going to work with this. Really very nice concepts. You cannot even believe that this clustering, Euclidean distance and Manhattan, even though it's a basic mathematical concept which are going to use in the cluster. Okay, so let us come back. Cluster analysis is a machine learning technique, you know this, and then the quality of the clustering results depends on the algorithm. So what happens, your people are going to have the data set, you are going to run on the algorithm, and then you are going to group all the similar data items at one place and all the different data items at the another place. Both together you are going to frame the cluster. Okay, so let us first find out how the clustering done based on the distance function. Okay, for this I have worked out some concepts. Okay, this for k means, yeah, can you guys able to see this? Okay, so this is what we are, there are two kinds of clustering. Okay, one is called as Euclidean and one more is called as Manhattan. Now what happens, suppose you this is what I'm going to have a x and y axis. Can you guys see it very clearly? Now what happens if I'm going to try to plot, okay, two points I'm having. I need to find out whether these points are near or different because I want to bring them in a single cluster. If I'm having x1 comma y1 and x2 comma y2, then I can very easily apply the Pythagoras theorem. Okay, so what this Pythagoras theorem says, you know, if I'm going to know x1 comma, okay, x1 comma x2 I'm having, and even similarly y1 comma y2, I'm going to apply the Pythagoras theorem. You know how the Pythagoras theorem works. It is nothing but ab square is equal ab square plus bc square, nothing but ac square. AC square is the distance now. Okay, this distance tell me that whether I am going to have one point nearer to another point. If it is far, then they are going to combine into the nearest point. If it is near, then we are going to combine. Are you guys understanding? So now what happens, you know, I'm going to say AC is equal to square root of AB square plus BC square. Now you know what is AB. AB is nothing but x2 minus x2 minus x1. AB is x2 minus x1. And what is BC? BC is nothing but y2 minus y1. Now x2 minus x1 whole square plus y2 minus y1 whole square. This is what I'm going to get a distance D, which is this one. That is nothing but called as Euclidean distance. Guys, this is how I'm going to find out the Euclidean distance in order to group the similar items in case of cluster analysis. Okay, coming back to one more type of technique that is going to be used is nothing but Manhattan. Basically, the Manhattan is going to be used in a developed countries. Okay, how they are going to be used in developed countries, I'm going to let you know. But before going to this, again, you people know if I'm having 2 points, okay, x1 comma x2, y1 comma y2, then I need to find the distance. Keep it in your mind, here we are directly finding the distance D by applying the Pythagoras theorem. But in case of Manhattan, we are not going to apply the Pythagoras theorem. Even though it's from a triangle, we are going to go orthogonally. What is the meaning of orthogonally? So similarly, x2 minus x1 whole square plus y2 minus y1 whole square, okay, then we are going to make it absolute. See here, D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is how I get the distance of D. But in case of Manhattan, D is equal to absolute. You know how to draw the absolute. Absolute of x2 minus x1 plus absolute of y2 minus y1. Means we are going to travel orthogonally. I'm not going to travel directly like this. Can you see this? I'm not going to travel directly like this to find out the point. I'm going to travel from A to B and B to C. That is nothing but I'm going to travel from x2 minus x1 plus y2 minus y1. This is how I'm going to travel in case of Manhattan. So these are the two very, very important techniques that is going to be used in clusters. Okay, that is nothing but we are going to call it as, basically, why we are going to use these techniques? We are going to use these techniques in order to find the distance. Why we need a distance? In order to group the similar data items. Whenever the distance is near, they are all going to come under one cluster, and whenever the distance is far, they are going to come under another cluster. This is how Euclidean distance and Manhattan distance is going to work. Euclidean distance is going to work on Pythagoras theorem. Manhattan is going to work on orthogonal direction. Now you people believe me, orthogonal direction, let me show you. Okay, yeah, where they are going to be used. Basically, the orthogonal directions, they are going to be used in developed countries. What is the meaning of a developed countries? Suppose you people can see, yeah. Just a minute, we'll show you what is the meaning of developed countries. Okay, yeah, fine. Now you people can see the table here. Now I want to travel. Okay, yeah, now I want to travel from this place to this place. Okay, so if I want to travel from this place to this place, if it was a Euclidean distance, directly I could have traveled like this. But actually it is a Manhattan, it is a developed country where everything is going to be developed properly, like roads, okay, and buildings. Now this is a road. If I take, I cannot travel across the building. If I'm flying in the flight, that is okay, but I'm traveling by walk. I cannot travel directly orthogonal, directly I cannot directly travel. So I need to travel orthogonally like this. Can you see this? Can you see this? Like this. Okay, so that is where your orthogonal direction Manhattan comes. Basically they are going to work very well in case of developed countries where everything is developed properly, roads and all. Okay, but when I come from Euclidean, the flight system can be a better example for Euclidean distances. Okay, so this is how the two very very important clustering techniques are going to be used. One is called as Euclidean distance, which is most intuitive measure, and one more is called as Manhattan. Never forget these two technologies, because this is the only one thing you are going to apply in the algorithms. So Euclidean is going to work on Pythagoras theorem, and Manhattan is going to calculate orthogonal direction, where we are going to make it absolute. When I say absolute, even though if you are getting a negative, you are going to make it as a positive. Okay, so x2 minus x1 plus y2 minus y1 absolute. That is what Manhattan will do. But actually Euclidean is going to do x2 minus x1 whole square plus y2 minus y1 whole square. Or even you can say square root of x2 minus x1 plus y2 minus y1. Right, this is how the clustering technology works. So here's the generic pseudo code. Okay, so just what I discussed now. Pick an arbitrary number of groups or segments to be created. Okay, start with some initial random choose. This is what similar to k-means algorithm. So we are going to work on this algorithm. Okay, I'm going to take a set of examples now which I have worked out, and I'm going to show you. Okay, so coming back, yeah, clustering exercise. This is what random numbers. Okay, this is what x and y numbers. Now we need to find the mean. Okay, so once we find the mean, we need to repeat the process. There are only three steps in the algorithm. Okay, first step is nothing but I will tell you. Keep it in your mind. This is similar to that of your k-means algorithm. Okay, similar to that of k-means algorithm. So what you need to do is, yeah, that's only here there are a lot of steps. Okay, so don't go for a lot of steps. Consider only three steps. What is this three step? The first step, keep it in your mind or note it down. The first step is nothing but just take the group of elements. Okay, kindly find a random numbers. Okay, it is left to you. If they are going to suggest you the random number, you need to consider that only. If they are not going to suggest you the random number, you have to find the your personal random number. Step one. And what the step two will do? Step two will tell you, okay, to find the mean of the random number. This is step two. Okay, find the nearest number of the number for the mean. Okay, you know what is the meaning of mean? Mean is nothing but average. You need to find all the nearest number of that particular random number which you have picked, of that particular random number mean. Okay, and the third is repeat the same process until and unless you are going to get the same mean. That I am going to show you the problem in the upcoming slides. Okay, so this is the only three things you have to do. Now what they are doing, again, the cluster exercise. There are a lot of points. Now if I want to go, okay, I need to find out whether 2 comma 1 I'm having 2 comma 4 and 4 comma 4. Now I need to find out which is the very nearest point which can get me in my cluster. Now what happened? Many people apply the Pythagoras theorem. Okay, apply x1 comma x2, y1 comma y2, and then you people apply the Pythagoras theorem and find out the distance, and which is near. Then you are going to group the clusters like this. Can I show? Yeah. Now you will see 2 comma 4, 4 comma 4 and 2 comma 6. They are going to be very near, so they are going to fall into one cluster. Similarly, in k-means, there are two types actually. One is divisible and one more is hierarchical. Okay, I'm going to say centroid. I can say centroid and hierarchical. I'm going to discuss that in upcoming classes. But this is general clustering I'm discussing, not k-means. Okay, so when I go into the k-means, I'm going to show you how the k-means work. Okay, so coming back, this is a generalized of the clusters, where either you can use Euclidean or Manhattan. It is left to you based on your requirements. So you know how both the works. Okay, very important thing. Euclidean is going to work on the basis of Pythagoras theorem to find out the distance, because when you find out the distance, then only you can decide whether they are going to fall into the same cluster or they are going to fall into the different clusters. Are you understanding? Okay, so in the same manner, you are going to apply the either Euclidean or Manhattan, and which are all going to fall into the nearest distance. They are all going to be formed into one cluster, which are going to become a far distance. They are all going to form into another cluster. This is how basically the cluster analysis is going to work. Okay, so coming back, as I told you, that's the algorithm of cluster analysis which I told you. Okay, here's the algorithm. Pick an arbitrary number of a group of segments to be created. Start with some initial random chosen values. Okay, then you need to classify the closest groups, compute new values of the groups, repeat the step 3 and 4 till the groups converge. They are going to become one. Okay, if the whole cluster is not satisfactory, then again you need to go for picking an arbitrary number, group the segments to be created, and you can do it. Okay, so coming back, yeah, this is one more very important algorithm that is nothing but called as k-means algorithm for clustering. Okay, so let me show you how the k-mean algorithm works. Okay, yeah, I will show you in detail. Yeah, okay, k-means algorithm again. If I am having a 60 number of the students, if I can see here, how to make a cluster of 4? This is a question. In general, if you want to say what you will say, sorry for the interruption. Yeah, this is about regression. Yeah, I was discussing. Can you guys see my image which I worked out? Very simple. Okay, so now if I am going to tell you that there are 60 students, okay, I need to make the group of 4. You are going to say very easily, divide them into group of 20 each. Then you are going to go 20, 40, 63 group of each 20. Then you are going to not 20, I can go for 15. Okay, 15, then you are going to get 4 cluster. This is how you can say by general words. But when I go for Amazon is very good example of clustering. Why? Because there is variety of products, around 4 crore products. Now, how you are going to group the products? You cannot say divide them into 3 or 4 very easily. That's a very big headache. Under that, even your Amazon, they are going to use k-means algorithm. Okay, so what is this? The k-means algorithm. Yeah, how they are going to divide? People can see the best example: grocery. All the grocery items, they are going to go into the grocery. I can say cluster group. Okay, and then bags. All the items which are related to bags, they are going to go into the bags. Electronic devices. All the items which are going to be in electronic devices, they are going to bags. Such a clustering is nothing but called as centroid clustering. Centroid clustering. Are you guys understanding? Right, so such a clustering where we are going to divide based on some of the properties or attributes, like grocery, all the grocery go to the one group cluster. Bags, all the bags come to the one group cluster. All the electronic devices go to the one group cluster. That is called as centroid clustering. But when you come for hierarchical clustering, where you are going to divide everything, for example, ed is nothing but electronic devices. Now people can say dividing electronic devices into mobile. Okay, fridge, AC, TVs. Now further in mobile, Apple, Samsung, Motorola. Again in Apple, iOS version. This all a tree-like structure. That is nothing but called as hierarchical structure. Okay, so now what happens? The k-means algorithm works in two concepts. Okay, step one is very simple. Take any random number, okay, out of a group. Then step 2, find the nearest number of the mean. Step 3, repeat the mean unless and until you get the same number of the mean items. So yeah, this is one of the best example for clustering of the elements. Okay, suppose I'm having k is my data set where I'm having the elements like this. Believe me, 2 3 4 10 11 12 20 25 30. Okay, they are the clusters. Just give me 1 minute. Just give me 1 minute. Just give me 1 minute. Okay, so thank you for hold. Just I was discussing the same thing. Okay, if k is nothing but here I'm having a data set 2, 3, 4, 10, 11, 12, 20, and 25, 30. They are the data elements. Now my question is I want to cluster these elements into two groups. Okay, so what I need to do, as I told you in my first step, I need to find if they have not given me the random number, I need to find the random number. Okay, so let me consider 4 and 12 as my random number. So now what happens? I'm going to find the nearest elements for 4. Okay, which is the nearest element for the 4? You people can see 2, 3, 4. How you can say they are very nearest? You subtract 4 by 3. What is the value? 1, which is nearer. You subtract 12 by 4. What is the value? 8. It is very far. So you cannot group that into K2. Okay. So like this, 2, 3, 4 are the elements we are going to fall into the nearest element for the 4. Now you take for 12. Okay, 12 minus 10, 2. So they are going to fall into the 12 group. 10, 11, 12 minus 11, 1. It is going to fall into the group. Now 20 minus 12, 8. It is going to fall into the group. 25 minus 12, again, what I can say, 8 plus 5, 13. They are going to fall into the group. Like this, once I get all the dividing the numbers, which is very near, I'm going to take the mean. Okay, what is the sum of this? 4 plus 3, 7, 7 plus 2, 9. 9 divided by 3. Okay, I'm going to get almost 3 as the mean. Round off. So if you are getting a point, round off, not a problem. Similarly, I'm going to get 108 divided by how many number of elements? 6. So what is the mean I'm getting? 18. Now again repeat the process. Okay, again you people can see. Are you understanding what I'm saying? Again you will repeat the process. Again you start to find out the difference. Take the 3 as your random number. Take the 18 as your random number. Now start matching. First set. Okay, K1. 2 is near to 3. Yes, 3 is near to 3. Yes, 4 is near to 3. 10 is near to 3 when I compare to 18. Yes, 10 is near to 3 when I compare to 18. So 10 is also going to fall into the K1 elements. Now you go for K2. Is 11 is near to 3 or 18? 11 is near to 18. So it is going to fall into 11, 12, 20, 25, 30. Okay. Again, you find out the mean. 19 divided by 4. Sum and mean. I'm going to get approximately 5. Now 4.75, but I'm going to round off to 5. Similarly, I'm going to get what? 19.6, which is going to be considered as 20. Now repeat the same process again. Take the elements. What is the next to my random numbers here? 5 and 20. Now you people again find out 2, 3, 4, 10, 11, 12. They are going to fall very near to 5. So they are going to be under one group. 20, 25, 30. They are going to be fall very near to 20. So they are in another group. Now again you try to find out. Yes, mute it. Again, you are going to find out 7 as a mean element and 25 as a mean element. Now you people can see when I'm again computing 7 and 25, I'm getting same data sets. 2, 3, 4, 10, 11, 12, 20, 25, 30. So what I'm getting mean is also 7 and 25. Thus, we are getting the same means. We have to stop the process. Now, which are all going to form into the cluster 1 is 2, 3, 4, 10, 11, 12. They are all going to fall under the cluster 1. And one, which is the elements which are going to fall into the another cluster? They are 20, 25, 30. Are you guys understanding? So this is how we are going to do cluster analysis. Okay, it is very important question, and this is what you are going to write the algorithm in a program to find out the clusters. Okay, this is I have shown in mathematically, but the same logic they are going to apply in the algorithm to find out the cluster. You believe me, even the biggest company like Amazon, they are going to use k-means algorithm. Okay, so for this purpose, I'm going to explain one more time. Kindly listen properly. You are going to have a set of the values. Okay, uh, just I'm taking general example. If you want to have a two clusters, randomly select two mean values. If they are not going to provide you the mean values, kindly randomly select the two mean values. Okay, so let me select a4. Why you are selecting 4? Okay, your choice select 3. Why you are selecting 12? Your choice select 11. It is left to you guys to select any random number, okay, which is going to act like a mean for the first iteration. So now once you select it, put every nearest element in the one cluster and one more nearest elements to the another cluster. How to put the nearest elements? You need to subtract. Now 4 is the element, 4 minus 3, 1, which is nearer. When you compare to 12 minus 4, 12 minus 4 is how much? Okay, 4 minus 2 you get 2. 12 minus 2 you get 10. So which is nearest? For 4, 2 is nearest. So 2 comes here. Similarly, 3. 4 minus 3 is 1. Similarly, 12 minus 3 is 9. So 1 is very nearer. So 3 comes into the cluster of 4. Like this, you are going to divide, okay, both into the different clusters, K1 and K2 clusters. Not a problem. If you want one more cluster, make it K3. And you need to select how many random numbers at the time? 3 random numbers. That is how the things goes. So now M1 is going to fall in this mean. Okay, you need to find out 3. Okay, this is how the things goes, and this is how the things goes. And finally, and you need to repeat the process. Step 1, find the random numbers. Step 2, find out the mean. Step 3 is repeat the process until the same mean you are going to get. Okay, so I have get the same mean here. So I have decided that my mean numbers are 7 and 25. When I'm getting same mean numbers, I will get my cluster elements. So I can easily say that now that cluster 1 belongs 2, 3, 4, 10, 11, 12. Cluster 2 belongs 20, 25, 30. This is how a k-mean cluster is going to work. This is what he is saying in case of centroid clustering. Okay, so it is an algorithm for k-means. K is nothing but number of clusters. D is nothing but list of data points. So can you see in our example? What is k? K is number of cluster. K is 2 here. What is d? D is number of data elements. Okay, instead of k, you make it as a d here. If you are seeing my image very clearly, instead of k, make it d here. Okay, d is nothing but number of data points. Okay, so 1 2 3 4 5 6 7 8 9, there are 9 data points. Okay, and how many number of clusters? 2 clusters. So that is what he is saying. Choose k number of random data points as the initial centroids. So I have chosen 4 and what is that, 12 as my centroids. Repeat till cluster center stabilize. Yes, I have done. Allocate each point in D to the nearest of k centroids. That is what I have done. 4 minus 2, 2. So it comes to the 2. 4 minus 3, 1. It comes to 3. That's what I am doing here. Right. So then compute centroid for clustering using all the points into the cluster and repeat the process until and unless you get the same mean. Once you get the same mean, you are going to stop the process and then you are going to divide the elements. That is what they have done here in case of a centroid analysis. Okay. So the same thing. Okay, came in algorithm for clustering. This all falls into the same cluster, so they go there. Here the cluster is 3. 1, 2, 3, 1, 2, 3. The cluster is 3. We have taken the example for cluster of 2. Okay, so whichever comes to this, they belong to this cluster 2, 6, 4, 7, 2, 4. Similarly, 8, 3, 6, 3, 5, 6, 6, 6, 5, 7. They are both in the nearest cluster. 4, 4, 5, 2. They are going to the one more cluster. This is how you are going to do the k-means algorithm. Really, guys, it is very important algorithm. You should never forget this algorithm. Why I am insisting and telling you more and more about this algorithm, because even a company like Amazon, they are going to take the help of k-means clustering. Okay, so this is how the k-means algorithm for clustering works. This is what they are shown in the diagrammatical representation, which you have shown manually in the work. Right. So these are how the things goes. Before going to that, I am having one more workout which I want to show you. This is all about finding out the cluster elements. Okay. So I'm having one more thing. Yeah. Same image as open twice. Yeah. Fine. Okay. There is two types of clustering I told you. Okay, K-means clustering. One is called as centroid and one more is called as hierarchy. So how this hierarchy going to work? In hierarchy, can you guys see here? Let me zoom a little. Okay. Yeah. Can you guys see now here? In hierarchy, there are two types of clustering. One is called as agglomeratic and one more is called as device. Okay, agglomeratic is nothing but it is bottom to top approach. Device is nothing but it's a top to bottom approach. Okay, so now what happens if it is an x-axis and y-axis? Now you people are think A is one element, B is one element, C is one element, D is one element, E is one element. Before clustering, I am saying. Now what happens? Just by seeing only, you can say A is very near to B, make a cluster AB. C is very near to D, make a cluster C and D. Now C and D is very near to E, make a cluster C and D. So overall cluster, one cluster. So what you are doing, A, B, C, D, E, A and B together form a one cluster. So draw a hierarchy. C and D is going to form one cluster, draw a hierarchy. CD is very near to E, form a one cluster. So draw a hierarchy. Now combining both A, B, C, D, they are going to form a cluster. See, now we are going from bottom to top. Okay, bottom to top. Such an approach is nothing but called as agglomeratic. This is a one way of hierarchical clustering. What we have seen, that is a centroidal clustering. Okay, so what we are seeing now here is a hierarchical clustering. Okay, so similarly, one more clustering is called as divisible. So what is this divisible clustering? Where you people can see, I'm coming from top to bottom. Okay, it is called as bottom to top approach, and this is called as top to bottom approach. So how it is there? Overall, we are having ABCD, divide that into AB and CDE. Further, it is going to be divided into A and B. It is going to divide into C and D. Further, CD is divided into CD. This is called as top to bottom approach. So this is called as divisible approach, and this is called as agglomeratic approach, where we are going to go from bottom to top, and here we are going to go for top to bottom. Okay, so this is what I need to tell all about K-means algorithm. So basically, K-means algorithm is of two types: centroid and one more is called as what I can say, centroid and hierarchy. So this is what the best example for centroids, which I have worked out with a numerical example and shown you. And when I come for hierarchy, I have shown you more examples. Okay, so coming back, let us see the advantages and disadvantages of K-means algorithm. So the main advantages of K-means algorithm is it's very simple. That's why the big companies are using. See how much big the company looks, that much simple algorithms they are going to use. Keep it in your mind. Google for email, they are going to use FTP only. FTP protocol, STP protocol. Okay, all basic protocols. But the company is too big. You cannot say Google has developed their own protocol. No. Today also the Google is using, in order to transfer the file email, they are going to use FTP. So how much the big the company is, that much simple algorithms they are going to use. So keep it in your mind. Amazon is also using a very simple algorithm. Okay. So what is this? The main advantages. K-means algorithm is simple, easy to understand, and easy to implement. Okay. One more, it is also efficient, in which the time taken to cluster K-means rises linearly with the number of data points. Yes. Initially, we have taken 9 data points. Okay, to find out the cluster. If it is 20, again linearly it will grow as the number of data points linearly. Y is equal to mx plus c. Linearly it is going to grow. Okay, linearly. So no other clustering algorithm performs better than K-means. Really, it's 100% true. When I come for disadvantage, the user needs to specify initial value of k. That is where I decided k is equal to 2. Why you cannot ask why you have taken k is equal to 2 only. It's left to you. You can say k is equal to 3 also. Okay. The process of finding the cluster may not converge. Yes, it is not suitable for discovering clusters that are not hyper. Okay. So which is very spear like, because we always linearly it will grow linearly. Okay. So these are the disadvantages of the cluster analysis. The same example you can work out. Now I need to find out the t-shirt size. Okay, based on the height and the weight. You can take it this example as this one as an example. Okay, height and weight, and you people can try to find out. People can find voluntarily. You can find out the rest of things. Okay, based on height and weight, you need to find out the t-shirt sizes, whether it's a medium, large, or small. Okay, take it as an assignment and you people can work out. Okay, so we left with two more concepts. One is artificial neural networks and one more is association rule. Okay, if I complete these two concepts, we are going to complete with our 4 modules. Okay, the fifth module is very easy. People will understand very clearly. Okay, so what is the artificial neural network? Okay, I'm going to discuss very basics. Okay, in the upcoming days, we are going to work similarly like K-means, we are going to work artificial neural network also. Okay, so with an example, I'm going to show how it is going to work. So coming back, ANN, again, it is inspired that an information processing model. It's going to be similarly, it has been inspired by human brain, I can say. ANN algorithm, artificial neural network, is influenced by the human brain because people started to thought or think how the human brain works. When they come to a conclusion that how the human brain works, they decided to develop the algorithm for that conclusion. Okay, so artificial neural networks is inspired and it's basically inspired for the information processing in terms of human brain. Okay, you know that human brain consists of billions and trillions of neurons. Okay, so every neuron carries some part of information. So every neuron receives some information from many other neurons. They are going to process it, they are going to excite it, and they are going to pass the information from one neuron to another neuron. So this is how the things goes. This is what made us to find out the artificial neural networks. Okay, so we are going to give the input. The number of neurons carry the information, and finally we get an output. This is how the artificial neural network works. Okay, so where we are going to apply artificial neural network. So let us see some applications where we are going to get work on the artificial neural networks. Basically, they are used in stock price prediction. You know, it's really a very big challenge, big game. So can you, anybody suddenly if I ask, can you tell me tomorrow whether the stock price go high or go down? You cannot say, sir, I'm going to go and ask the astrologer. Nowadays, your all machine learning is an astrologer. You need to ask them. And how they are going to say you? They are going to apply some supervised learning techniques. And finally, they are going to say yes, whether tomorrow the stock price is going to go high or going to go down. Right? So that is where again our ANN is going to helpful. Okay, ANN is an example for your artificial neural network. Example is stock price prediction. Okay. The second is character recognition. Yes, nowadays crimes are happening very much. Okay. Someone has written the letter and died. The whole mystery starts from there. You need to start using the recognizing the handwriting. Again, the artificial neural networks helps there. Okay. Again, there are you also used in traditional classifying problems such as upgrowing your loan. Yeah, in olden days, it was quite difficult to decide whether to give the loan or not because people used to individually talk, walk to their homes, see their home. Even they could have shown the beside people's home as their own home, and they could have get the loan. Yes, there are many incidents that has happened in the previous. When I go for past 20 years, if you want a loan, it was very easy because you can fake very easily. But today, all this algorithm is not so foolish that they will going to approve your loan very easily. They need a lot of work. That is why they are going to collect a lot of data sets from you, where you are working, okay, what is your salary pay, whether it is a permanent employee, you get the certificate from there. This all these data sets they are going to input into the model. And once they are going to give input into the model will give the output, accurate output, accurate, not the exact output, accurate output. Based on this prediction accuracy, you are going to come to a conclusion that yes, whether we need to provide the loan or not. Right, guys? So this is how does the application, basic applications of ANN, artificial neural networks. Okay, so we are going to see how really the artificial neural networks works in the upcoming classes. With respect to the top association rule, keeping in mind, if I'm going to complete this both, believe me, we have completed almost 4 modules. So we're left with only one module, that is the last module. Okay, so let me put the attendance before leaving the class, so that I need it very badly because we are keeping track of attendance of you guys. Yes, I think if you can see my share, there is a question paper also, but I don't want to open that presently. Okay, so yeah, Where is the attendance? Oh, I think I have closed it. Just to unmute and tell you attendance. Yeah. Okay, fine. Can you guys listen to me? Kindly tell your attendance once. I'm going to call it to your name or number. It's Ghulam Hussain. He's present. Guys, tell me your attendance. Hurry up. Ghulam Hussain. Okay, Salman.
Present, sir.
Yashas. Usharaj.
Present, sir.
Okay, Dilip. Gayatri. Jeevan. Anjushri.
Yes, sir.
Pooja Priya. Varun. Rakesh. Tanuja.
Present, sir.
Shrija. Bhavya.
Attendance of sorry.
Kiran. D. Lavanya. Abhishek. Adrin. Afshan. Aishwarya. Akshata.
Present, sir.
Akshata is there. Okay. Amulya. Anupama.
Present, sir.
Apurva. Akshita. Ashita. Bhagyalakshmi.
Present, sir.
Bhumika. HR. Bhumika TR.
Present, sir.
Bilwa.
Present, sir.
Bilwa Prasad.
Present, sir.
Brinda.
Present, sir.
Chandan.
Present, sir.
Chandrasekhar. Karan.
Present, sir.
Chinmay. Darshini.
Present, sir.
Deepak.
Present, sir.
Present, sir.
Okay. Deepika.
Sir, Vinay
Present, sir.
Just wait a minute. I'm going to call you. Deepika. Okay.
Present, sir.
Deepika Rani.
Sir.
Deepti.
Present, sir.
Deepti. Present. Okay.
Present, sir.
Disha. I'm going to get the count. Don't worry. I'm having screenshot also. Okay. Even I have taken the screenshot of your participation ID. Later I'm going to verify it. Don't worry. Disha.
Present, sir.
Divya Bai.
Present, sir.
Ishwararya.
Present, sir.
Gagan. Gitanjali.
Present, sir.
Suddenly from 70 plus 86 participation has gone. Nice. So take the attendance first only. Gautami.
Present, sir.
Hema. Hema absent. Okay. Hemant. Absent. Jayant.
Present, sir.
Jyoti.
Present, sir.
Kamlaksh. Kavyasri.
Present, sir.
Kamlaksh is there. Kavyasri. Kavyasri is not there. Okay. Lekhana.
Present, sir.
Madhura.
Present, sir.
Mamata.
Present, sir.
Manasa.
Present, sir.
Mandara.
Present, sir.
Meghana. Okay. Zaid.
Present, sir.
Adita.
Present, sir.
Natraj. Nikshit. Nikshita.
Present, sir.
Nishchita TS.
Present, sir.
Nishmita HM. Padmashri.
Present, sir.
Anchami.
Present, sir.
Praveen.
Present, sir.
Priyanka.
Present, sir.
KM.
Present, sir.
Yes.
Present, sir.
Rakshit. Rakshita.
Present, sir.
Rohini.
Present, sir.
Rukmani.
Present, sir.
Ruksar,
Present, sir.
Sanjay, Sanjay, Sharmila,
Present, sir.
Shashank, Sheetal,
Present, sir.
Shilpa,
Present, sir.
Shilpashri,
Yes, sir.
Shushruta, Pintu,
Present, sir.
Saurabha,
Present, sir.
BS,
Present,
Saurabha BS,
sir.
Srijit,
Present.
Sriram, Sriram, Srishti,
Present, sir.
Yas,
Present, sir.
G,
Sir, Nane B. Present, sir.
TL Ilvana,
Sir, TL illa.
okay. Sukruta, Sunita,
Present, sir.
Sushma,
Present, sir.
Venkatesh,
Present, sir.
Abasum,
Present, sir.
Tejas, okay. Tanushri, Tanushri, Tejas, Tejas T. Goda, Upara Manjula, Varshini,
Present, sir.
YS,
Present, sir.
Vatsala,
Present, sir.
Veena,
Present, sir.
Vidya,
Present, sir.
Vijayashree,
Present, sir.
KS,
Present, sir.
Vinay,
Present, sir.
Vinita,
Present, sir.
Vismaya,
Present, sir.
Vaishnavi,
Present, sir.
Yashaswini,
Present, sir.
Ritesh, Ritesh Illa, Manjunath,
Present, sir.
okay. Emma,
Present, sir.
Nikita,
Present, sir.
Nishita, Nishita
Present, sir.
okay. Ramya,
Yes, sir.
Vidya, Vidya, okay. Fine. Guys, this is all about your assume attendance, okay.
Nishmita present, sir.
Okay. And you put me a message and I'm going to write, okay. You have any doubts with respect to the top internals, because next week when I'm taking the class, almost your internals will be finished. Any doubts with respect to internals? Feel free and ask now itself. Any doubts with respect to internals? And kindly take that undertaking of travel history, fill it and send. Those my proctor or anybody's proctor, kindly do it. Okay, and take your internals well. It's not so difficult. Okay, refer the textbook. Okay, in the textbook you will get everything. I can say that. Okay, so try to do it promptly, at least thinking about the exams. Okay, don't think about only the internals, and don't think that exam will not be there. When we are conducting the internals, why then the university like VTU can conduct the exam? Okay, so don't be into the dilemma. Fine. So I'm going to make Sujit as a host, and then I'm going to leave the class. Aishwarya M became the host. How come? Sujit. Okay. Aishwarya M, you have become a host. Kindly give the rights to KP sir when he is going to log in. Okay. Okay, thank you.
Yes, sir.
Thank you.